short compared to all the rest of them. So let's not even waste time. How would we get water to flow faster out of this pipe? Twist the knob. That's what most people say. They say turn the knob, twist the handle, increase the pressure. You turn the knob, you're going to increase the pressure on that. Okay. How would we get, what are two things we could do to slow the flow of water? Turn the knob the other way. What's something else we could do? Tighten the pipe. Anything else we could do to stop the flow of water through this pipe? We already said that. Anything else? Like if I had water running right, oh, I got stuff in there. If I had water running right now and I wanted to stop the water, what could I do with my hand maybe? Put your hand in front of it, right? You can turn the knob the opposite direction. You can cover the opening of the pipe, anything like that. If I were to decrease the width of the pipe, what would happen to the flow of water then? Nothing. If I made, like, so the pipe is like this and then I'll say I made it smaller, what would happen to the flow of water then? Would the flow decrease? Huh? It'll slow down, something like that. People say something like that from what I saw today. If we were to make the pipe 10 times longer, if we were to just make this 10 times longer, what would happen to the flow of water then? Nothing. Like instantly, like in that moment, what are you gonna have? Like in that moment, like say like right now, I just made it 10 times longer. What do you think would happen to the flow of water? It wouldn't change, right? I've heard some people say it will slow down. I've heard people say it wouldn't be affected. I've heard people say it get faster. It's opinionated, right? It will take longer. Cool. So we only have 11 days of school left. Keep pushing. That's really nothing. We have 12 summators instead of 10. Please be reminded, in order to be exempt from our final exam, you have to complete summative 9, and you cannot have any I's in any other summatives. Okay. I already explained why. And let's talk about what you have left. You had a due now on last Tuesday. You had an exit ticket. I exempted everybody from the ed puzzle on Wednesday because I didn't feel like making it. On Friday, you had a due now. You had an exit ticket. You just did your due now today. That means you only got these things right here. You can see what they're about. And then I'm probably getting rid of this final exam review game because most of my kids are not taking the final anyway, except the ones that's taking it. So I ain't about to play no review game if y'all ain't taking it. So I'll probably just put that in as extra credit, or just be a free 100. Then you got a little survey and that's it. Cool. So let's go ahead and get this show on the road. In August, when I first met you all, we talked about physical quantities. They could be scalars or vectors because our lives are governed by physical quantities. And we talked about a specific one called motion and how things move. And we talked about how they can be represented graphically. And we talked about how they can be represented algebraically. And it took a whole 3 months to do all of that. Then we talked about how nothing would move unless a force acts on it, correct? Then we talked about how when forces cause things to move, that's called what? Close. But when forces cause things to be displaced, that's called what? Work. And we know that machines help make work easier. And then we know that there would never be any work if there wasn't what? Energy, which is the ability to do work. Then we know that that energy can be transferred from place to place. And now we're on our very last topic of the whole school year, because I just love my job, clearly. And just what we said, I was going to teach the kids the whole content. It's going to be kind of lame and beginner, and we ain't going to get as advanced as we would have. But we're going to talk about an energy that everybody loves, because if we didn't have this energy, Shamar, our lives would suck. And you wouldn't want to be here. And if it were to disappear right now, everybody would die. And that may sound like a little bit extreme because people live without it for so long. But literally, if you think about all the things that are controlled by this specific type of energy, if you think about every hospital that's literally thriving on that, like, people would be dying. And if things started happening and we couldn't go to the hospital because there was like no electricity, or our car batteries didn't work because that runs on electric, like we would die. So this is our last standard. We're talking about electrical and magnetic force interactions. We're going to be talking about magnetic force. Today, we're going to talk about voltage, resistance, and current, and it should be done by, I say, 10:15. What is this? What is this? This is an atom. This is an atom, and it's actually an atom of lithium. I know it's lithium because it has 3 of these things. Anybody know what those are? Ooh, review. Nope. These are protons, right? I can't even look at my chat box. People probably saying stuff. It has 3 protons. It also has 3 neutrons, right? Neutrons have no charge. What are the charges of protons? Positive. What are these little yellow things outside? Those are electrons, and what charge are they? Negatively charged, and they're the stars of the show for these last 2 days I'm gonna be teaching y'all. And the reason they're the star of the show, because that's where they got the name from, electricity. These electrons, and everything has them. You have them, I have them. Everything that exists is made of electrons, protons, and neutrons. And people knew about electricity for a long time. They knew even before they started doing special stuff with it. You could like get shocked by touching people, or lightning would strike and people's hair would go up. What type of electricity is that? Anybody know? When you rub your feet across the carpet, and static electricity. And I used to have a lesson about that, but I ain't got one this year because I ain't teaching it. Cool. But it became very important, Shamar, when this man decided to fly a kite in a thunderstorm. He had a little key on it, and then the key became electrified. And that was important, Michaela, because that's when they figured out electrons could move through and across things from place to place. Because until they figured that out, if they didn't figure that out, if somebody didn't sit down and care about physics, we'd be in here in the dark. You wouldn't be looking at anything on the screen. You couldn't be on your laptop. You couldn't text Bay. You couldn't expose nobody. It's like you wouldn't have anything. Your car batteries wouldn't work. You wouldn't have been able to be here. It would suck. We would not want to be living if they never figured out how to move electrons from place to place. And that's called current, Shamar. Current is the rate at which electrons move. They found out that electrons can be sent from one place to another. When they found that out, they sent it to some glass, and the glass got hot. Some of the glass started producing light. We got light bulbs, and we have so many things that go on because current is the rate at which electrons move. Where else have you heard the word current? Have you heard the word current before? I know you have. We hear current when we talk about water a lot, and that's what I'm going to use to teach you about the things that affect current. My do now was the way it was on purpose, as usually all of them are, so that it would go a little bit faster. Y'all ready? Is the current of water coming out of this pipe low or high right now? I think it's quite low. What can we do to increase the current out of this pipe? Turn the faucet, right? We're gonna turn the first of all, y'all need to appreciate this because I did this myself. We're gonna turn the faucet. You see the little white hand right there? You see it's turning? I did that. Okay. And then we had some water coming out. Did the current just increase? It did. What can we do to increase the current even more? Turn it some more. Turn it some more. It's turning, you see it? And boom, the current increased, didn't it? So the electrons began to move. What causes something to move? Ever. Because this is not going to move until I apply something to it. Force, right? And then when it moves, I just did what on it? I just did what on it? Because my force just caused it to be displaced in that direction. What's that called? What? Voltage, Shamar, is the work that must be done to move electrons between 2 points. Because the electrons wouldn't move unless there was something doing work on it, correct? Yes. Awesome. You see this circuit up here? What up there do you think is doing the work to push the electrons through the circuit? Is it the light bulb? Batteries provide voltage in the circuit. They are the things doing the work to get the electrons moving through the circuit, right? Because we have the negative electrons coming out the negative side. How are they getting through the circuit, you think? What's pulling them through the circuit if they're coming out the negative side? The positive side of the battery, right? And that's how it works. Same. Voltage is the work that must be done to move between 2 points. Have y'all seen these things on the screen? If you wanted your phone to charge real fast, which one would you want to use, Shamar? The 10 one. Do you know why? Has a higher voltage. Kindergarten physics today? Kindergarten physics? Kinda. Anybody confused? You know what I'm about to ask you next? Which circuit has a higher amount of current? YB. Higher voltage. I'm glad, because last class period they kept saying it was bigger. We don't want to talk about the size of the battery. We want to talk about the voltage, correct? Mikhail, you know what I'm about to ask you next? You should know, because I've been talking about relationships all year. So if that's the case, voltage and current have what type of relationship? Direct or inverse? Direct. You confused? Y'all confused? Probably. I ain't really even talking to him. I ain't even facing the mic no more. I just been talking to y'all. I'm so sorry. Cool. That makes sense. What can we do to decrease the current? You said what? Without touching the faucet. Uh-oh. What screw? What screw? The screw on the faucet? Cover the pipe somehow, correct? Yeah. Anything else we could do? Could I change anything about the pipe? Because we can't touch the faucet. So we're gonna cover it up. So can I change anything about the pipe? What can I change about it? Because we know which pipe up here would have the fastest current. The one at the top, just like when people have clogged arteries, it's stopping the blood flow in their body, right? This is called resistance. What does it mean to resist in general? To resist something. If I resist arrest, what does that mean? To fight against. Resistance is anything that opposes electrons. What in this circuit do you think would be getting in the way of electrons? What in these circuits would be getting in the way of electrons? Because students don't really think about it like this, but how? The who? No. In the circuit. The circuit is this thing we're looking at. We can't see no photon. The wires could. What's that? What else? I only got so many things in the circuit. Light bulbs provide resistance in circuits. Do you know why? Because most students get confused by that every time because they think about what light bulbs do for us. But the more light bulbs you add to this, do you think the light bulbs get brighter? They get dimmer, Shamar, right? The more lights you turn on. And that's because, okay, also the density or material of the wire can do that. Here we got electrons running track. What can we call that? What the heck are you even talking about? We got electrons moving, is what I've been talking about today. It's the whole subject of the lesson. This could be described as current, couldn't it? I'm just making a point. I also made this gift. Every time the electron has to go through a light bulb, Shamar, it's essentially like a hurdle, right? It's something that it has to go through. And the more hurdles you add, what's going to happen to the flow eventually? It's going to begin to slow down. If you're running around the track and nothing's on the track, can you run fast? If you have to jump through a bunch of hurdles, are you going to slow down? Yes, you are. So increasing the resistance does what to the current? Decreases the current. You know what I'm about to ask you next? Resistance and current have what type of relationship, direct or inverse? If you increase the resistance, what's going to happen to the current? It's going to decrease. Does that make sense? Good. It's 10:10. I said I was going to be done by 10:15. Which circuit up here has a higher amount of current? Why is it circuit A, Shamar? Do you see why she said that? Because last class period, they were confused. But it has something to do with what we just talked about. Why does it circuit A have the most current? Yes, or we could say it has less. Yeah, less light bulb switches, less what? What was the word I just talked about? Fighting back. It has less resistance. Do we see that? This has more stuff to go through. That one's going to flow faster, right? But it also has less resistance because the batteries have the same voltage, right? Because what if circuit A had a 30-volt battery? Would it have less current then? No. So the batteries have to be the same, but the voltage has to be the same, right? Come on. Which has more current in this one? Circuit B. Why? It has more voltage. Do we see that? What else do you notice? The resistance is also equal because if this had a higher voltage, but it had 10 light bulbs in it, do you think that would matter? Yes, because it would make the current lower, right? So I hope you see what I'm saying. Which has more current now? Uh-oh. Why circuit A? It has less resistance, but it also has less voltage, Shamar. Do you see that? So which one is it? Why is it circuit B? What'd you say? What'd you just say? Oh. Which one? Which one? Which one? Which one? Which one? Which one? He said, Mr. Makers, oh my God. Which one? Guess what? We don't know. I was waiting on somebody to say it. Usually a kid says it eventually. I don't know. All right. We don't know. Guess what? You got to do math for that. You got to do math for that. Y'all see this? Shamara says V is equal to I times R. What do y'all think that means? Is equal to. Good. I ain't saying nothing about no I, so we probably don't know what that is. But what's R? Resistance. So what you think I is actually? Close, but no. Voltage is equal to current times resistance. Don't ask me why I stands for current. I just work here. Okay, it's been that since I was in high school. It's probably because C is taken up by something else that I can't remember right now. But voltage is equal to current times resistance. V stands for what? Voltage. The unit is volts, and you can write a V. I stands for what? Current, and the unit is amps. R stands for resistance, correct? The unit is ohms. You can write an omega. Y'all ready to do this? Which circuit has more current? Let's start with circuit A. What am I about to do? Because this is the last time, this is the last math problem we ever gonna do. Can I pull the stuff out the circuit first? Do we have a voltage? It's 6. We see it sitting right on the battery. Do we have a current? What is it? You sure? We don't know because it's asking us to find the currents, isn't it? What about resistance? How did you get 2? No. How did you get 2? Yes, because we need to get the total resistance. If each light bulb is 1, and we have 2 light bulbs, Shamara, what are we going to do? Add them guys together to get the total resistance? And it's 2, like she said, before I confused them. Y'all ready? The formula, Mikayla, says what? V is equal to I times R. Shamara, what should this look like? Six is equal to I times 2. What are we doing now, Mikayla? To get I by itself, even though we should really look at I and just know what that is 3 already. But we're going to divide by 2 on both sides because maybe sometimes my problems might be decimals and we can't just do it in our head. What's the answer? 3 amps. Why is it amps? That's the unit for current. Y'all confused? Guess what? Yeah. Calculate the amount of current in circuit B. Are we about to do the same thing we just did? Do y'all see the voltage? Do you see the current? No, because that's what we're trying to find. Do you see the resistance? We got how many resistors up here? 4. Is that the resistance? It is actually. Why is the resistance 4? We got 4 light bulbs and each got 1 ohm of resistance. Does that make sense? Cool. What would happen to the current if I took this battery out and made it 6? What would happen to the current if I used wire that was 2 times thinner? And that's today's lesson. And it's 10:16, like I said. I didn't even say no. All right, thank y'all. If you have any questions, let me know.